we ended up with the startups, and now I come from a company which did not end and is a long time startup. Primeo Energie was founded 125 years ago, and we are still alive. Okay. So that's a map. That's northern Switzerland, and if you look at the map, we are serving with our distribution company not only Switzerland but also in France. And so we have two regulatory schemes in Europe. It's quite difficult because the country sizes are different. So we are an international distribution operator, and also in Switzerland we are in different cantons active. Uh, we have four businesses what we are really dealing in. One is the electricity business, the other one is distribution, where I'm responsible for. Then we have large heat systems in France and in Switzerland, and we are in renewable energies all over Europe. So mostly of the renewable energies we do not produce in Switzerland because of regulation, because of non-acceptance of windmills and things like that. So we go abroad to France, to Italy, to Spain, to Germany, where we can really build those wind farms and solar power plants. And in Switzerland, it's difficult to do so. So the evolution of the Swiss electricity system, as the president of ETH Zurich, Joël Meso, already told this afternoon, is that in Switzerland we have more production of energy in summertime, and in wintertime we don't have enough energy. So in wintertime we import energy, and in summertime we export energy. And when you look at it, you see it, this is only for a 2024 picture. There we didn't import so much in wintertime because it was not a strong winter, so we had enough energy in Switzerland. And you see the red part on it, that's the photovoltaics. And photovoltaics, I come later to it, that's a headache for every distribution system operator, because they are distributed at the end of our lines. And if there's too much energy at the end of our lines, the voltage rises and I have problems to have the stability inside. So if you look at the Swiss consumption, once again, we import in winter, we export in summer. It may vary. The production is not stable. So if you have hydropower is not stable. If you have a dry summer, you don't have production. And it's not only solar or wind, which is not does not give a band. It's also hydropower, which is very much depending on water. So it's not a very stable system. And also the consumption in Switzerland, it's not a consumption which is flat. So we have some years with a lot of consumption and other years with very few consumption. Then in Switzerland, you see, I said, you don't import here in Japan. It's zero, electricity. I mean, fossil fuels, you import. We have 100% fossil fuels, but electricity we do some imports, and I don't know. Maybe you tell me that you have some lines to other countries. What we have in Switzerland, what also already was mentioned by Eric, we have this battery. We have this water battery in Switzerland with 8 terawatt hours storage capacity. This is 12% of the annual consumption. And this would help to make summer and winter to make that equal. But it's not managed by the Swiss government. It's managed by the companies. And I mean, they sell the energy when it's at highest price, and they sell it not only to Switzerland, they sell it also abroad. So it's not a Swiss battery, it's a battery owned by the different companies. And you see here, there is also a minimal mark there. There is the reserve in Switzerland where they say you cannot uh, uh, get the battery fully empty. You need some reserve. If there's a blackout or a shortage, then you need something, some space in there. And now I come a little bit to my headache. That's the production of solar power in Switzerland. You see, it's increasing a lot. It has now come to a little bit a stop to it, not a stop, but the increase is not that high anymore. And on the other hand, I have another headache. The headache is the one in pink, and the one in pink, that's heat pumps. So heat pumps are becoming very popular, and the heat pumps, they do not pump heat unless they do not have electricity. So I need to design the network also for heat pumps. And heat pumps is usually when it gets cold all over Switzerland, and all the heat pumps are running. So that's the same with the solar panels. When the sun is shining, they are producing all the same time. If you think of electric cars charging, they do not charge all at the same time. But PV panels and heat pumps, they are at the same time. Your network needs to be designed for. And that's also a distribution of how you do the uh, distribution here in Switzerland for heating. And you see the green one for the new buildings, that's also the heat pumps. And it's now the standard for the buildings. A big increase. I think in Japan you have a lot of heat pumps, as I read in the internet, but I'm not sure if that's really true. Okay. Now, what's the challenge of a electricity distribution operator in Switzerland? One of the biggest challenge we have is that we have so many distribution system operator in Switzerland. So we have roughly 600 distribution system operators, and you have to get industry standards. And so you have to discuss with each other to have to be aligned as distribution operators, that you serve your customers according to the standards, which are not always written, but are industry standards. So you need to coordinate 600 distribution operators. That's a challenge for the operators. We would like to be fewer. Huh? It would be easier. Huh? It would not be easier only for the customer, it would also be easier for the distribution operators. So then what we did is an analysis of our distribution network, how this will be influenced by the heat pumps and the solar panels. What is the capacity? And we did this for different years with different scenarios, which the Swiss government made these scenarios, how Switzerland's electricity uh, will evolve. And we looked for different scenarios, and we need to redesign our network. And on the left-hand side, you see the load, and on the right-hand side, you see the infeed. What we have both sides we have to design for. It's not only load, it's also infeed, where we have to design our network. And so we make calculations, and we ended up in knowing which lines are overloaded at what time. And so we now know where to increase our or to refurbish our lines, and how we have a program to install new lines. And one of the things what we did, that we need to increase our medium voltage level. We increase our medium voltage level to which was historically set to 13,000 volts of medium voltage. We will set that now to an international standard of 20,000 volts, 20 kilovolt, which is known in France, in Germany. I don't know, in Japan you have different systems. So that's a usual standard, and there we can save money in order how we increase that. What we also have a problem, and that's maybe a European problem. When I was here in the looking on the streets, a lot of distribution systems are overhead lines, and the European standard is in the ground. And if you look, that's a road, and you have the sidewalk, and under the road you have different uh, things in there. You have gas lines, you have telecom lines, you have water, wastewater, and you have electricity. And the roads are full. If you are in an urban thing, the roads are full. You don't find space for new lines. So you need to be creative in order to coordinate all that. There is also the buzzword flexibility. And flexibility is in order to adapt our customer, that they adapt to our loads. So if there is heavy load on our network, that they reduce their consumption or reduce their infeed. So there we have two different concepts, and these concepts are uh, here not to invest in copper, not to invest in lines, but to invest in the behavior of our customers. And the behavior of our customers, there are 2 points which you can do. You can have this demand side management, where we really manage the system of our customers, or just demand side response, where we just give them a price signal. We give them a price signal. Now it's we have heavy traffic on our lines. It gets more expensive, and if you use the distribution network, then it will cost more. So we are investing also in these 2 points. Regulatorily, that's new now, really allowed to do so. Beforehand, it was not allowed, only in a special setting. Now, for the 1st of January next year, we can have now dynamic tariffs for electricity. And thank you very much for your attention.